Hello there! A big hello from your notes Nandan. Welcome to Outclass. How have you been? Huh? Doing great, huh? Nice. Last time out, we read about decimals, right? And today, I have something interesting for you all. Angles, angles, angles. I'm angling myself to introduce the concept to you. Let us learn more about angles in today's Outclass. In class 5, you would have learnt about dividing a circle into different parts, right? Using a set square, yes. Just to remind you, a set square looks like this. It is a triangular instrument that is right angled at the vertex. Right? When we place the set square at the center of the circle, we can draw lines along the sides of the set square to divide the circle. The number of parts created would depend on which vertex of the set square is placed at the center. If we place the right angled one at the center, we can say each part will make an angle of 90 degrees. The total angle at the center is 360 degrees. So if each part is 90 degrees, we get 4 parts. If we use the other two vertices, right, the angle made by the set square would be 45 degrees. And hence, the circle is divided into 8 parts. Wait. Notes Nanda. How do we find out what the angle is in the first place? Huh? Good question. Let us look at that now. To begin with, let us find a small angle with which we can measure other angles, right? This is done by dividing the circle into 360 equal parts. The measure of this angle is 1 degree, written as 1 with a small circle on the top. An angle twice as large would be 2 degrees. Thrice as large would be 3 degrees. Just like we add millimeters, we can add degrees as well. 2 plus 3 degrees is 5 degrees. No, what's Nanda? How do I measure the number of degrees? Only then I can add, subtract and all that, no? Yes, we use a protractor to measure the angles of different sizes. A protractor looks like this. It has markings that are 10 degrees apart. That is, it can be used to measure 10 degrees at a time. And the total angle that can be measured is 180 degrees. As shown in the pic, the angle made by the bottommost line and the first line above it is 10 degrees, right? And that is shown by the number 10 that is written at the end of the first line. Now the number at the end of the second line is 20, right? Which is the angle made by the line at the bottom and the second line. That is 20 degrees. Now, how do we use a protractor? If we have two lines at an angle to one another, we place one of the lines along the bottom line of the protractor, which is 0. Then we observe the other line in the diagram and note the number it's pointing at. The number on the protractor it points at, and the number it points at gives the angle between the two lines. Now, for example, right, one line is aligned to the bottom, that is the 0 degree line, and the other line points at the number 130. Then it means the angle between the two lines is 130 degrees. Now, that's how in the beginning I found out the angle at one of the vertices of a set square is 90 degrees. Simple. Take a set square and draw its outline on a paper. Then align your protractor where one line is at 0. Then you will notice one of the vertices, right? That line will align itself to the number 90, which means the angle at that vertex is 90 degrees. Similarly, If you measure the other two angles, you will see it is 45 degrees. When two lines are at 90 degrees, we can see that they are perfectly straight and bent. Huh? None of them are slanting. Angles with value greater than 90 are called obtuse angles. Angles with value less than 90 are called acute angles. Angles making a perfect 90, right, are called right angles. This is how 90 degrees looks, right? Without even measuring, I am able to say the angle is 90 because of how straight the lines are. In this case, the upper line has been moved towards the bottom one, right? So I know the angle has reduced from 90, right? Which is less than 90, which means the angle is acute. If the upper straight line is pushed away from the bottom line, the angle is increased, right? Increased to a value above 90, thus giving us an obtuse angle.